So next question is 5. Question number 3 and 19 was of the same type. Now this is new type. Two identical positive charges are fixed on the y-axis at equal distances from the origin O. A negative charge particle starts on the x-axis at a large distance from O, moves along the x-axis, passes through the origin and moves far away from O. Its acceleration A is taken as positive along the direction of motion. The best graph between the particle's acceleration and its x coordinate is represented by. तर चार ग्राफ आपल्याला दिलेले आहेत. तर त्यातले बी आणि डी तर रॉंग आहेत हे लगेच आपल्याला सांगता येऊ शकेल. पण त्यासाठी आपल्याला काही मॅथमॅटिकल इक्वेशन डिराईव्ह करायला लागतील. सो सिच्युएशन ऑफ द प्रॉब्लेम इज लाईक दिस. Suppose this is the origin O. Say this is point A where plus Q charge is kept. This is point B where again plus Q charge is kept. This distance is D. These two charges are equidistant. This distance is also D. So these are the two charges. Now say at point P, a minus Q charge is kept. These two charges are static charges. This is a movable charge. So it is moving in this direction. So it will approach the origin and then it will cross the origin and it will go on the negative x-axis. So this distance we have denoted by x. So different distances we have denoted like this. And now if you join OP, this is equal to R. If we join BP, it is also equal to R. So these are the different distances. AO is equal to BO is equal to D. OP is equal to X, it is a variable. AP is equal to BP is equal to R. And this angle is 90 degree. Therefore, the in triangle OAP or OBP, R square is equal to D square plus X square, Pythagoras theorem, like this. So this is equation small a. Now this is negative charge, this is positive charge, so there is a force of attraction between them. So we will denote that force as F. Same force is here because distance is also same, charges are also same. So this angle is theta. This angle is theta. So if we draw perpendicular, then this component is the F cos theta. This component is the F sin theta. This component is the F cos theta. This component is the F sin theta. Like this. So when movable charge movable charge minus q is at point P at distance r from each fixed charge plus q, then force of attraction on minus q due to each charge plus q is F is equal to q into q upon 4 pi epsilon naught r square in magnitude. So this is equal to k into q upon r square. This is equation 1 in magnitude. Where k is substituted for 1 upon 4 pi epsilon naught. F is directed along PA and PB as shown in figure. Then F sin theta component of two forces cancel each other. See, they are equal in magnitude, opposite in direction. Cancel each other, where theta is equal to angle OPA is equal to angle OPB. Both angles are same. Actually, this is a isosceles triangle. So P point lies on the perpendicular bisector. Therefore, these two angles are same. This is 90. This is 90. This is 90 minus theta. 90 minus theta. This is theta. So this is the geometry. So F sin theta component cancel each other, but F cos theta component of the two forces are in same direction, along x-axis, directed from P to origin O. See this. Therefore, F cos theta component added to produce a resultant force R equal to F cos theta plus F cos theta is equal to 2F cos theta. So this is equation 1. If M is equal to mass of movable charge then R is equal to mass multiplied by A. Therefore, acceleration A is equal to R by M is equal to this equation, K into Q into small q upon M into R square. This is equation second. Sorry. What to substitute the value of R, and value of R is equal to 2 times f cos theta upon M, and this is equal to, now substitute the value of f. So acceleration A is equal to 2 multiplied by f. The value of f is equal to k into q upon R square. This is M into cos of theta. This is equation second. But cos of theta, but in triangle OPA, cos of theta is equal to x upon R. Therefore, putting 2, so acceleration A is equal to 2 upon M q into k into q upon R square x upon R. So this is equal to 2 times k into capital Q into small q upon M into x upon R cube. X upon R cube. This is equation 3. From equation A, R is equal to x square plus d square raised to 1 half. Therefore, acceleration E. Therefore, आपल्याला ॲक्सलरेशनचा ग्राफ काढायचा आहे, त्यासाठी आपल्याला इक्वेशन माहिती पाहिजे. ॲक्सलरेशन A इज इक्वल टू 2 into k into capital Q into small q upon M into x upon x square plus d square raised to 3 by 2. This is equation capital A. This is equation capital A. So without knowing the equation, we cannot give the correct graph. Now we can get some idea which graph will be correct. Case A, case 1, when x is equal to 0 at origin, then acceleration A is equal to 0. Acceleration A is equal to 0. Therefore, B and D are wrong. दोन ग्राफ कट झाले, कारण तिथे x इज इक्वल टू 0 ला ॲक्सेलरेशनची व्हॅल्यू 0 नाही दाखवलेली. Now the remaining quantity is this. Now x is equal to 0, A is equal to 0, it is shown in graph A and graph B. Now, what is the result? So, acceleration A will be maximum when dA by dx is equal to 0. याचा डेरिव्हेटिव्ह आपल्याला घ्यावा लागेल. सो दिस क्वांटिटी इज कॉन्स्टंट आणि याचा डेरिव्हेटिव्ह फक्त आपल्याला घ्यावा लागतो. सो इट गिव्स dA by dx is equal to 0. We can show that x is equal to it is the loop d by root 2. So at x is equal to plus minus d upon root 2, A will be maximum. A will be maximum. And for minimum value 0, again you have to use this same method. So graph of A against x is this is 0 0 origin, this is x is equal to d upon root 2, this is x is equal to minus d upon root 2, this is double value. So we have fixed this point. Case second. At x is equal to 0, A is equal to 0, so this is the first point. At x is equal to d upon root 2, this is maximum and it is positive. It is negative because of minus sign. And at x is equal to it is maximum. So the graph is like this. So this is plus x minus x plus A minus A. So correct graph is in C. C is correct. Actually, we have given the sign convention. The acceleration is positive in the direction of motion. So from this point to this point, it is minus. Now as the charge goes on this side due to the inertia, the force will bring it in the opposite direction. So motion will start in this direction. So motion is opposite to the minus x direction and therefore minus sign. So the two graph will be like this. One is below x-axis, other is above x-axis, like this. So without this equation, we cannot conclude about the graph. So we have to derive this equation. But once we know, then we can get this idea. Actually, in this case, the charge is minus and both the charges are positive. So it is attracted like this. When it reaches the point A, the two attractive forces will be like this. The force of attraction due to the charge plus Q at A will be in this direction. Due to the B, it is in this direction. So these two forces will cancel. So definitely the force will become zero. Means the body will come in equilibrium. Now, due to the inertia, it will go in this direction. So, minus q charge is moving in this direction, but plus q charges will attract them. So, it will perform oscillatory motion. And oscillatory motion has graph like this, sinusoidal or cosine function like this. So, charge is negative and therefore it has this type of nature. So, this type of question is also asked. What is the about the motion of the charge? So, the charge will oscillate like this. Due to the force of attraction, it will move from P to O. Here it is in equilibrium, net force is zero. Due to the inertia, it will go in this direction. Again, due to the attractive forces, it will return to the origin like this. So, it will perform simple harmonic motion. So, motion of the charge is the oscillatory motion. So, that type of question is also asked. So, you can add one more conclusion. That is minus q charge will perform oscillatory motion about origin, that is x is equal to 0. It will perform oscillatory motion. So this type of question is also asked. Logically we can say that it will perform oscillatory motion and it is like this. Next, question number 6. These questions are somewhat lengthy, but conceptually they are very important. A solid sphere of radius r1 and charge density rho is equal to rho 0 by r is enclosed by hollow sphere of radius r2 with the negative surface charge density sigma, such that the total charge in the system is 0. Rho 0 is a positive constant and r is the distance from the center of the spheres. The ratio of r2 upon r1 is. तो प्रॉब्लेममध्ये आपल्याला व्हॉल्यूम चार्ज डेन्सिटी पण यूज करायची आहे आणि सरफेस चार्ज डेन्सिटी पण यूज करायची. सो वी हॅव टू यूज दॅट कन्सेप्ट. सो अरेंजमेंट इज लाईक दिस. सपोज दिस इज ए hollow sphere of radius r2. It has surface charge density sigma. The charge is negative minus q2 because it is a negative surface charge density. Now there is this outer sphere number 2. This outer sphere encloses the inner sphere 1 whose radius is r1. This is a solid sphere. Its surface charge density is rho. This charge is plus q1, and the net charge is 0. So addition of these two charges will be 0, like this. So we have to find r2 upon r1. R2 upon r1 is equal to question mark. Let q1 is equal to charge inside sphere 1. Therefore, q1 is equal to volume charge density multiplied by volume of the sphere 1. So q1 is equal to rho into 4/3 pi r1 cube. This rho is equal to rho 0 by r, rho 0 by r 4/3 pi r1 cube. So this is q1. This is equation 1. Since volume charge density of sphere 1 is rho v is equal to rho 0 by r. Rho 0 is constant, therefore rho v is inversely proportional to r. R is distance from center of the sphere. Therefore, as R increases from 0 to R1, rho v, and hence rho v decreases inversely proportional. Therefore, Q1 is obtained by integration method. So why we are using integration method? The reason is this: it is equal to this R is equal to 0, R is equal to R1 into volume charge density multiplied by volume of spherical shell of radius r and thickness dr. अपन इतना चार्ट करते हैं. So this is from lower limit 0 to maximum limit r1. Volume charge density rho v in this volume is equal to 4 pi r square dr. So this is equal to integration from 0 to r1 rho 0 by r into 4 pi r square dr. 4 pi r square dr. So one r will get cancelled, and therefore Q1 is equal to 4 pi rho 0 constant integration of r dr from lower limit 0 to upper limit r1. So this is equal to 4 pi epsilon naught integration of r को पढ़ा अपन कैलकुलेट के लिए it is r square by 2 lower limit 0 upper limit r1. So this is equal to 4 pi rho 0 constant into r1 square by 2 minus 0, and therefore Q1 is equal to 2 pi rho 0 r1 square. This is equation 1. So value of q1 is equal to this. Charge inside the sphere is equal to 4 pi r0 r1 square. 4 pi rho 0 r square pi 2. Now we have to find the charge q2. Let q2 is a total negative charge on sphere 2. Therefore q2 is equal to, आता इथे इंटिग्रेशन में करते गरज नाही, कारण आपल्याला सिग्मा दिलेला आहे. So this is equal to surface charge density charge current area minus n multiplied by surface area of sphere 2 of radius r2. Therefore q2 is equal to minus n for negative charge into 4 pi r2 square. This is equation 2. This charge is negative. Let q is equal to total charge of the system of two spheres. Therefore q is equal to q1 plus q2, but q is equal to 0. Therefore 0 is equal to q1 plus q2. Therefore minus q2 is equal to q1. This is equation 3. Put 1 and 2 in equation 3. So minus sigma into 4 pi r2 square is equal to, the value of q1 is this, 2 pi rho 0 into r1 square. So minus sign will get cancelled, pi will get cancelled. So 2 times sigma into r2 square is equal to rho 0 r1 square. So we have to find ratio r2 square upon r1 square is equal to rho 0 upon 2 times sigma. Therefore the ratio of r2 upon r1 is equal to under root of some constant upon 2 times sigma. This is the ratio of the two radii, and therefore the correct answer is C choice is correct. No logical argument. C is correct. तर सिस्टीम इक्विलिब्रियम मध्ये पाहिजे असेल तर टोटल चार्ज 0 पाहिजे, पण टोटल चार्ज 0 म्हणजे q1 q2 जे येते इक्वल इन मॅग्निट्यूड ऑपोजिट इन साइन पाहिजे. तर एक चार्ज निगेटिव्ह आहे, हा पॉझिटिव्ह आहे, सो addition will be 0, and this is possible only when the ratio of r2 upon r1 is equal to like this. So what we use the concept of surface charge density and volume charge density. Linear charge density means charge per unit length, surface charge density means charge per unit area, and volume charge density means charge per unit volume. So linear distribution is 2-dimensional distribution and 3-dimensional distribution. We have seen this type of uniform charge distribution. Here to find the charge Q1 inside this first sphere, inner sphere, we have imagined this spherical shell whose radius is r and thickness is dr. So this volume of this spherical shell is equal to surface area 4 pi r square multiplied by dr, and in this volume there are dq coulomb charges. So when we integrate that dq, we will get the total charge. Integration will be from r is equal to 0 to r is equal to r1. So first sphere has radius r1. So limit of this integration r from r is equal to 0 to r is equal to r1. So as radius of the center of the sphere, as r increases from 0 to r1, these are the limits. 0 to r1 rho v decreases. म्हणजे सेंटरला चार्ज जात असणार आहे आणि ह्या फर्स्ट स्पिअरच्या सर्कम्फरन्सकडे जाताना चार्ज कमी कमी होत जातोय, पण टोटल चार्ज आपल्याला एवढा मिळतो. Next, actually this type of problem we have solved in our regular session board book. Two unit negative charges are placed on the straight line. A positive charge Q is placed exactly at midpoint between these unit charges. If the system of these three charges is in equilibrium, the value of Q in coulomb is तर सिस्टीम इक्विलिब्रियममध्ये केव्हा येते, तीन चार्जेसपैकी कुठल्याही चार्जेसवरती फोर्स टोटल फोर्स 0 व्हायला पाहिजे, कुठलाही चार्ज, आयदर एंड चार्जेस ऑर center charge. So the arrangement we will show by figure like this. This is the straight line. This is point A. This is point B. This is center C. So this charge is Q1. It is a negative charge. This charge is Q2. This is a negative charge, and this charge is plus Q, positive charge. So Q1 is equal to 1 coulomb, Q2 is equal to 1 coulomb, Q is equal to question mark. The magnitude is it. So the system is in equilibrium. When the system of three charges is in equilibrium, then force acting on net force, resultant force acting on any charge will be 0. Consider forces acting on Q1 kept at point A. Let FAC is equal to force of attraction exerted on Q1 by Q. Therefore, this is equal to Q1 Q upon 4 pi epsilon naught AC square. So the distance is D. The distance is D by 2. The distance is also D by 2. So FAC is equal to Q1 into Q upon 4 pi epsilon naught D by 2 bracket square. So FAC is equal to Q1 Q upon 4 pi epsilon naught D square by 4. So that is equal to 4 times Q1 Q upon 4 pi epsilon naught D square. This is equation 1 in magnitude. So this FAC is directed from A to C. FAC. Let FAB is equal to force of repulsion. Force of repulsion exerted on Q1 by Q2. Therefore, FAB is equal to Q1 Q2 upon 4 pi epsilon naught AB square Q1 Q2 upon 4 pi epsilon naught D square. This is equation second in magnitude. So I will show this force like this. It is the force of repulsion. Charge Q1 at point A will be in equilibrium when FAC and FAB balance each other. Therefore, FAC is equal to FAB. This is equation 3 in magnitude. So put 1 and 2 in equation 3. So FAC is equal to, this is the value of FAC, 4 times Q1 into Q upon 4 pi epsilon naught D square is equal to equation 2 Q1 Q2 upon 4 pi epsilon naught D square. So 4 pi epsilon D square cancel, Q1 cancel. So 4 times Q is equal to Q2. Therefore, Q is equal to Q2 by 4. That is equal to 1 by 4 coulomb. That is equal to 0.25 coulomb. So Q is equal to 0.25 coulomb. So the correct choice is D. D is correct. So here, considering the forces at on minus q1 at point A, we can also use q2. समजा आपण जर फोर्सेस क्यूवरच्या घेतल्या तर क्यू क्यू कॅन्सल होऊन जातो आणि आपल्याला क्यू वन क्यू टूमधलं रिलेशन मिळेल. आपल्याला क्यू कॅल्क्युलेट करायचं आहे म्हणून एक तर हा एन चार्ज घ्यायचा, ए पॉईंटचा मायनस क्यू वन चार्ज किंवा बी पॉईंटचा मायनस क्यू टू चार्ज घ्यायचा. So either consider the force on the charge minus q1 at A or minus q2 at B, then we will get the same answer because system is in equilibrium like this. Okay, we will stop here.